Oil spills are a major environmental factor that endanger wildlife and ecosystems worldwide. It is important to efficiently remove this oil in order to protect these environments from further damage following a spill. Ferrofluids provide a viable option. A ferrofluid is a magnetic liquid to safely and effectively remove this oil from the water in an oil spill cleanup. In a study conducted at the Massachusetts Institute of Technology, researchers tested the ability of oil-based nanoparticles to remove oil from water. This study found conclusively that oil spill removal was more efficient when methods involving ferrofluids and magnetism were used in addition to traditional methods of absorbent materials. This flowchart depicts the standard procedure followed during the experiment, as the independent variable was the concentration of microparticle added to the ferrofluid, and the dependent variable was the efficiency of oil removal after 15 magnet passes. As showcased by this trial run, a ferrofluid was created by adding a microparticle to the oil. As the oil coated the iron oxide, it became oleophilic and aquaphobic, which means it repelled water and remained suspended in the oil. Then, a plastic bag was placed around a neodymium earth magnet, and it was then submerged into the oil 15 times. Each time, a paper towel would dry off the remaining oil and water. After the end of 15 trials, the remaining oil and water levels were measured in the graduated cylinder. The remaining levels were then recorded in the graph. This experiment was conducted 4 times for each concentration of 0, 3, 6, and 10% concentrations of the microparticle added to the ferrofluid. The following table depicts the before and after water and oil levels in milliliters, as well as a corrected milliliters of oil afterwards, for comparability. The following graph shows the averages of each of the concentration groups and their oil efficiencies after 50 magnet passes. As the p-value was lower than 0.05, which is the alpha value, there was a significance in the data, specifically the 0.67 concentration group. But this experiment raised one more question. Does the size of the particle really matter? Utilizing 3 different sized particle groups, the average diameter of each group was measured using a digital microscope. Not surprisingly, the only group that succeeded in creating a ferrofluid was the smallest group, with the average diameter of 1.2 micrometers. In conclusion, this study indicated that certain concentrations of the micro-sized magnetic particle did remove more oil per passes than others, specifically the 6.67 concentration group. Additionally, individual measuring yielded that the smallest group with 1.2 micrometers as the average diameter was able to remain suspended in the oil and allow for oil removal. Further research might yield a critical size and/or concentration of particle necessary to optimize the removal of oil from water. Thank you.